In this lesson, we will be solving equations with radicals. Just like what we've learned previously, we need to isolate what we're trying to solve for. So we've done problems with absolute value, we've done problems with just solving for variables, where the key idea is to get rid of everything that's around whatever we're trying to solve for by undoing the problem. Okay, so that's what we're going to try to do now. When we have a radical in the problem, we need to get it to where the radical is on one side of the equation by itself if we can. Okay, so let's take a look at a couple examples where just where there's only one radical and it's on one side. Okay, so let's look at example A. We have um, a radical x minus 5 equals 4. Okay, well in this case we need to isolate this radical x. Okay, so we're going to add 5 to both sides. Okay, so that gets rid of that, and now we have radical x equals 9. Okay, now as you've learned previously, the opposite of a square root is squared. Okay, so earlier we had, if we had x squared equals 9, what we would do is we would take the square root of both sides in order to find what x by itself would be. Okay, but now when we have the square root of x, we need to square it in order to find what the x is. So we're going to square both sides. Okay, so when we square both sides, it's going to give us x equals 81, okay, because the square root and the square undo each other, okay? Now we're left with x equals 81, so we're going to move on to this next one and take a look at this. This one is already isolated. If you take a look at it, there's nothing that we can get rid of because the x minus 5 is all combined on the inside. So we need to realize that this entire thing is being square rooted, okay? So we're going to work this one uh, by squaring both sides. Okay, and that is going to leave us with just x minus 5 on one side, and it's going to leave us with 16 on the other. Okay, and our last step is going to be to add 5 to both sides, and we'll be left with x equals 21. Okay, very simple solutions. You just need to understand that whenever you square a square root, then everything on the inside will still be there, just without the square root sign around it. So it works out pretty good. Okay, so let's scroll on down to look at example 2. Okay, example 2 says radicals on both sides. Okay, very similar. When we have radicals on both sides, it's okay. We're still going to do the same process. It's just a matter of making sure that we don't accidentally forget our square root sign. So what we're going to do here is we have the square root of this equals the square root of that. So what we're going to do is we're going to square both sides again. Okay, so that cancels off those square root signs with the squareds. Okay, so that takes care of that, where we have 3x minus 4 equals 2x plus 3. Now I believe this is an equation that everybody's familiar with how to do, so we're just going to get our variables on the same side together. Okay, so that's going to get rid of that, and I'm going to go ahead and pull my constants over to the other side. So I'm going to go ahead and add 4 to both sides. Okay, that's going to leave me with just x equals 7. All right, so pretty basic ideas when you have just basic radicals. I want to warn you though, there are some situations where some of the answers that we'll get will not actually work if you plug them back in. Some solutions, maybe you have a negative, which if squared would give you a positive, and so it kind of messes with what the possibilities are that you could get as a solution. So you really always need to go back and check to make sure that it makes sense. Okay, so let's take this one for example. If we squared both sides to be able to get rid of the square root, then we'd have x squared equals x plus 12. Okay. Um, the only solution that we know how to solve this type of equation is to set it equal to 0. So let's bring this over. Okay, over to this side as well. All right, so we have the quadratic of x squared minus x minus 12 equals 0. Okay, so we can factor that to be able to get x minus 4 times x plus 3 equals 0. Okay, and when you do that, as we know from the cover-up method or the zero product property, we know that we would get x equals positive 4 and negative 3. Okay, so that would be my two solutions. Okay, so we need to go back and we need to check those two solutions to make sure that they work. Okay, so we need to plug them back into the original equation and just check and see if they work. So let's say 4 equals the square root of 4 plus 12. Let's just check that. Okay, we're trying to see, is that true? Okay, so 4 plus 12 is 16, so we have 4 equals the square root of 16. Is that true? Well, what's the square root of 16? It's 4. 4 equals 4, so yes, that one does work. Okay, so let's check negative 3. We say negative 3 equals, we wonder, to the square root of negative 3 plus 12. Okay, what is negative 3 plus 12? Well, it's positive 9. Okay, what's the square root of 9? It's positive 3. Are those equal? No. So therefore, this one does not work. So you cannot include that as a solution. So therefore, the only solution that works is going to be x equals 4. Okay, so make sure to be careful about that because these extraneous solutions are solutions that do not satisfy the original equation. You might find the solution, but it may not always work. So you always need to go back and check, make sure it works. Okay, it doesn't take very long to plug that back in. All right, so we're going to take a look at one more. Okay, if we work this problem, we would first isolate the variable. Okay, so we need to subtract 8 from both sides, and we get square root of 3x equals negative 6. Okay, so I'm going to square both sides, and that would give me 3x equals, because that cancels off, 3x equals 36 divided by 3, and I get x equals 12. Now, before I circle that, I need to check it. So I need to plug it in. Square root of 3 times 12 plus 8 equals 2. Make sure you don't put that 8 under there. Okay, so that's going to be 36, or the square root of 36, plus 8 equals 2. So don't forget we're checking this. We don't know for sure. Okay, what's the square root of 36? It's going to be 6 plus 8 equals 2. Okay, 6 plus 8 is 14. Does that equal 2? No. So if there was only one solution that we found and it doesn't work, then the answer is no solution. All right. So I hope that you remember to check those because we'd hate for you to do all that work, think you got the right answer, and then realize that if you would have just checked it, then you would realize it doesn't work. So be careful about that. This is your final lesson by video for this year. Good luck on your final, and have a good day.